Welcome to the next session on ANSYS Workbench tutorials. In this session, we are going to analyze the disc brake rotor design 1 that we have created for modal analysis. So we will start by double clicking on modal module of ANSYS Workbench. Next, I'll go to geometry and right click. I will import the geometry of the disc brake rotor. Next, I'll go to model and double click on it. We will go to mesh and change the sizing to fine and update. Next, I'll go to model and I'm going to insert fixed support on these surfaces. Apply. Next, I'll go to solution and I'm going to insert deformation total. Next, I'll go to solution and solve. Now I'll go here and I'll right click and select all. I'll right click and create mode shape results. I'll go to solution and solve again. You can see here these are the natural frequencies, the first 6 of them. I got 6 because when you click on analysis settings, the max mode to find is 6. If you reduce a count, you will get lesser number of frequencies. If you increase a count, you will get more number of natural frequencies. So we will see the first deformation over this body. As you can see, the frequency is 5342.4 Hertz. And this is how your body is going to vibrate under this natural frequency. You can see the total deformation is 61 mm. Next, we will see the deformation 2, and this is how the body is going to deform. It is 5342.4 Hertz. It's the same value. So we'll go for the third one. The third one has a frequency of 5399.1, as you can see. The first two are actually the same. Here the deformation is 87 mm, and this is the pattern in which the disc brake rotor is going to sway from side to side. The next one is 5403.1 Hertz, and the deformation will be 87.29 mm in this case. Now, if you observe the natural frequency, the value is quite high. So, if your body in which this disc brake rotor has been fitted doesn't reach this natural frequency, then there won't be any resonance and there won't be any deformation or distortion to this extent. But suppose if it goes to a natural frequency of this high value, then in that case you will see a deformation of 87.29 mm, and this kind of a motion in the disc brake rotor is bound to happen. So to avoid this, we have to see to it that the vehicle in which the disc brake rotor has been attached doesn't reach this natural frequency, and here the natural frequency is really high, so it's really good that it won't reach this high natural frequency. Next we will see the natural frequency of 5596.7 Hertz. Here I can see this is the fourth mode of vibration. This is how it is going to vibrate. And here you can see the deformation has reduced. It will be 80.26 mm. Next we will go for mode 5, where the frequency is 5868.6 hertz, and the deformation is 79.07 mm. Again, the value is further reducing if you see. Though the natural frequency is increasing, the deformation is reducing. And the last one is mode 6, for which the natural frequency is 6591.7 hertz. You can see the deformation has increased as compared to the previous two. It has become 84.92 mm. And let's see how it is going to vibrate. You can see that this is going to vibrate in this fashion. But the only relief is the deformation is high, but the natural frequency at which this kind of a motion is going to happen is really very high. So that's how it is going to show this kind of motion. Now, if you observe, I have not changed the material. I was just using structural steel for it. So I will go and add new material. I just wanted to change the material at this stage and see its result. So I can use stainless steel and I can use cast iron. I'll go to project and update project. In this way, you will to know if there is any effect of material on these values. So I'll just solve once again using grey cast iron. You can see these values have reduced. So total deformation now is 64 mm and natural frequency is 4114.9 hertz. The previous material was structural steel. Currently it is grey cast iron. Now again these two will show the same value, so we'll directly jump to the third one. Here you can see that the deformation is 91.066 mm for a frequency of 4162.6 hertz, which means this value has exceeded structural steel. Next value is 90.848 mm for a frequency of 4165.5 hertz. That is the third mode. This is how it is going to vibrate at this natural frequency. Next we will see the mode 4, where the frequency is 4325.8 hertz. The deformation you can see is reduced at this point. It is 83.69 mm. You can animate and check the result. We'll go for the fifth mode, which has a frequency of 4534.4 hertz. The deformation you can see has increased to 82.559 mm. And then the sixth one has 88.62 mm as a deformation for a frequency of 5107.4 hertz. So this is what you obtain. Now suppose if I change this material to steel, I want to know whether steel is good in all the three parameters, that is structural analysis, thermal analysis and modal analysis. If it is so, as compared to grey cast iron, then I would prefer making my disc brake rotor using stainless steel. And grey cast iron doesn't stand in all three cases, so it is not required to be used at all. So if I have to choose, I would choose stainless steel. So you can see here, rightly said, all the frequency values are higher as compared to grey cast iron. We will also see the deformation, it is lesser. So let's check for all of them once again. At 5296.8 hertz, the value of deformation is 62.26 mm. And this is how the body is going to vibrate. We'll go for third one. Deformation is 88.22 mm. And the frequency is 5350.2 hertz. You can check the animation. For the third mode, the deformation is 88 mm and the value is 5354.4 hertz. You can check the animation. The fifth value is 80.84. Here the value reduces for all the three material. So this is something which you can note, that at this point for all the three materials that we have checked, structural steel, grey cast iron and stainless steel, the value of deformation reduced at this point and at a particular frequency which was obtained at this mode. This is possible because of the way in which it is vibrating. So the deformation is lesser. Whatever is the value of frequency, we will always find the deformation has reduced at this point. At this point, again, you have seen a decrease in deformation like your structural steel, but in grey cast iron for this mode 5, again the value had increased. But here the value has decreased to 79.56 mm. Value of frequency is 5809.3 Hertz. And the last mode where the frequency is 6515.7 Hertz, the value of deformation is 85.51 mm. So if given a choice, I would choose stainless steel over grey cast iron. Structural steel was not supposed to be used in any way. I just used it initially because I wanted to first find out if the material really affects the natural frequency of the material. That is also something that you got to learn using this analysis, that yes, material definitely affects the natural frequency of the body because it is the property of the material to vibrate in a certain way. So with this, I end the session. I hope you have understood how to analyze this disc brake rotor for modal analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.